Introduction to Logarithms. Let a, b, and c be positive real numbers, such that b is not equal to 1. The logarithm of a with base b is denoted by logarithm of a to the base b and is defined as c equals logarithm of a to the base b if and only if a equals b to the power of c. Reminders: in both the logarithmic and exponential forms, b is the base. In the exponential form, c is the exponent. This implies that the logarithm is actually an exponent. Hence, logarithmic and exponential functions are inverses. In the logarithmic form, logarithm of x to the base b, x cannot be negative. Let's illustrate. 3 to the power of negative 2 equals 19 means logarithm of 19 to the base 3 equals negative 2. X in our illustration is 19. Even if the base is raised to a negative exponent, the answer is still positive, and that is why the logarithm of a number cannot be negative. The value of the logarithm of x to the base b can be negative. Example, if we try to evaluate the logarithm of 1/8 to the base 2, we ask, what power of 2 gives 1/8? The answer is negative 3. Negative 3 is a negative number. Take note that the logarithm of a number cannot be negative. However, the value of the logarithm of a number can be negative. Common logarithms are logarithms with base 10. For example, logarithm of x is a short notation of logarithm of x to the base 10. Natural logarithms are logarithms with base e, approximately 2.71828, and are denoted by ln. So ln x is another way of writing logarithm of x to the base e. Let's have some illustrations from exponential form to logarithmic form. 5 cubed equals 125. In the logarithmic form, that is logarithm of 125 to the base 5 equals 3. Or 3 equals logarithm of 125 to the base 5. 5 here is our base in both the exponential and the logarithmic form. In the exponential form, 3 is our exponent, while in the logarithmic form, 3 is the logarithm. So the exponent is actually the value of the logarithm of a number. Write each exponential equation in logarithmic form. We have 4 squared equals x. Our base here is 4, while 2 is the exponent. So it is written as logarithm of x to the base 4 equals 2. The base remains the same, which is 4. And remember that exponents are logarithms. 1/8 equals 2 to the power of negative 3. Our base is 2 and our exponent is negative 3. So it is written as the logarithm of 1/8 to the base 2 equals negative 3. E to the power of x equals 2. The base e is an example of a natural logarithm, so we can write this as ln 2 equals x. Rewrite each logarithmic equations in exponential form. Logarithm of 64 to the base 2 equals 6. Our base is 2 and our logarithm is 6, so we can write this as 2 to the power of 6 equals 64. The base again remains the same, and the logarithm is the exponent. Logarithm of m equals n, so this is an example of a common logarithm with base 10, so we can write this as 10 to the power of n equals m. Logarithm of 81 to the base 3 equals 4. The base is 3 and the logarithm is 4, so we can write that as 3 to the power of 4 equals 81.